Yes.
Why?
Why did we get rid of grade level? Yeah, Zello's done. And it's for like the students who need to do like go to certain classes to get extra stuff done where they're assigned so they can work through their stuff. All right, so today we're going over equations of hyperbolas. So similar to an ellipse, a hyperbola is the set of all points in a plane such that the absolute value of the differences of the distances from the foci is constant. Every hyperbola has two axes of symmetry. You have the transverse axis, okay, and you have the conjugate axis. Okay, so on these two pictures here, your conjugate axis is between those C values. Okay, so it is your shorter axis. Okay, that's your conjugate axis. Your transverse axis is the longer one between your vertices. Okay, so both of these points are vertex points. Your transverse axis is between those two. Okay, the foci of a hyperbola always lie on the transverse axis. Okay, you have your focus points lying on that transverse axis. The vertices are the endpoints of the transverse axis. The covertices are the endpoints of the conjugate axis. As a hyperbola recedes from the center, both halves approach asymptotes. I want to highlight that. Okay, these approach asymptotes. Those are lines that the hyperbola does not touch or cross. Okay, so your hyperbola can't go through those lines. Those are the dashed lines in your picture right here. Okay, so these are your asymptotes. Okay, your hyperbola has to go around those. It will never intersect those dashed lines. Even if it continues on, it'll get closer to those asymptotes, but it'll never go over it. So an asymptote is where your graph, any graph, if it has an asymptote, it will never cross over that. Okay, it'll get closer and closer to it, but it'll never go over it. So as with ellipses, there are several important relationships among the parts of hyperbolas. There are two axes of symmetry. Again, that's your transverse axis and your conjugate axis. And then the values of A, B, and C are related by the equation C squared is equal to A squared plus B squared. So in your ellipse, it was A squared minus B squared. In your hyperbola now, it is A squared plus B squared. Okay, and just like ellipses, we can use those different axes to find A and B. So your transverse axis is equal to 2A, and your conjugate axis is equal to 2B. So again, we can use those axes to find A and B. So looking at our chart below here, we do have the standard form of our hyperbolas, and they are still centered at HK. Okay, again, H is always next to X, and K is always with Y. Now, yes, it looks similar to an ellipse, except you have subtraction between instead of addition. Okay, and your A squared value is always the one out front. Okay, it's not the largest number this time. Okay, it can be smaller, but it's always the number out front. Okay, B squared is the one in the middle here. So that determines if it is horizontal or vertical. Again, we have our equations for our foci points, our vertices, and our co-vertices, just like we did for ellipses. They're pretty much the same. However, we also have equations for asymptotes. So the part that I want you to always look at for your asymptotes is the slope. Okay, so you can use the slope of your asymptotes in order to find A or B. Okay, because that slope is plus or minus B over A, or it's plus or minus A over B. So you can always use that to solve for A or B. Okay, questions before we do a couple examples? Writing an equation of a hyperbola. All right, then we have two different examples here. Okay, we're solving them different ways. So you're given a graph, and we want to write an equation for that hyperbola. So first I want to decide if this is a horizontal or vertical hyperbola given that graph. So your vertices are right here on that graph. So this line between those vertices is your transverse axis. Okay, since your transverse axis is horizontal, that means this hyperbola is horizontal. Okay, so this hyperbola is horizontal, meaning our equation is in the form x minus h squared over a squared minus y minus k squared over b squared is equal to 1. Okay, and I have different steps to find different things just like we did for an ellipse. So step 1 is to find the center. Okay, I want to find the center point between those two vertices. Okay, so we are going to use the midpoint of the vertices. Okay, I have one vertex right here at -2, -6, and one right here at 8, -6. Okay, so I need to average my x's, so that's 8 and -2. So we'll add those together, so -2 plus 8, and divide that by 2. Same thing with our y values. So we have -6 and -6. So add those together and divide by 2. So we're just finding the midpoint of the vertices. That'll give us our center. Okay, so I have 8 minus 2 is 6. 6 divided by 2 is 3. -6 plus -6 is -12. -12 divided by 2 is -6. Okay, so our center point on our graph here is at 3, -6. So that's our center right there. Now our center is at h, k. So we now have h and k. So I still need to find what a and b are. Okay, so step 2 is to find a, because I can see I have that transverse axis drawn in. So we are going to use the transverse axis. Okay, so use that transverse axis. So we want to figure out how long that is. Okay, each of these goes up by 2. Keep that in mind. Okay, so we have 2, 4, 6, 8, 10. Okay, so your transverse axis is 10 units. Now your transverse axis is also equal to 2a. So we have 2a is equal to 10. So we just have to divide that by 2 to get that a value. Okay, so now I have HK and I have A. Now, to find B, I would need the covertices or the conjugate axis. In my graph here, I don't have any covertices or conjugate axis labeled. Okay, that means I have to use these foci points right here to find C, and then using C, I can find B. Okay, so step 3. Is to find C. Okay, and we want to use the foci points. Okay, so I'm going to use one of my points for a focus point. Doesn't matter which. I can either use -3, -6, or I can use 9, -6. So I'm just going to use -3, -6. Now the value that you're looking at in your focus point is the one that changes. Okay, so between my two focus points here, my y value stays the same. They're both -6. So I need to look at this -3 part. Now in order to get that coordinate, if you look at the table on the front, you would have to take your h value plus or minus the c value. Okay, so that's what this coordinate, this x value, is equal to. So I can set -3 equal to our h value, which is +3. Then I have plus or minus c, because I want to find what c is. So I would subtract 3 here to get -6 is plus or minus c. And your a, b, and c value should always be positive. So I would just take the absolute value of that to get c is 6. Okay, so now that I have this c value, I'm able to find the b value. Because of that equation on the front, we have c squared is equal to a squared plus b squared. So I have a and c, so I can then solve for b. So that'll be step 4 here. Is to find b. Okay, and we're going to use c squared is equal to a squared plus b squared. Okay, so I have my c value, it is 6. So I can square that to get 36 is equal to our a squared value. A was 5, so that's 25 plus b squared. So just subtract 25 from 36 to get 11. And take the square root of both sides. So we have the square root of 11 is equal to b. And I want you to leave it like that. Don't plug it into your calculator and get a decimal. Because remember at the end here, when you plug it into your formula, you have to square it. And when you square a square root, you're just going to end up with 11 then. So leave that as a square root. Don't get it as a decimal. Okay, so now that I have H, K, A, and B, that's all I need to plug into my form here to write out this equation. Okay, so our last step is to write the equation. Okay, so we can write out our x minus our h value, which is 3, square that, over a squared, so 5 squared is 25, minus, since this is a hyperbola, it is subtraction, our y value minus our k value. Since it's minus and negative, we can just write plus 6, that quantity squared, over our b value squared. So square root of 11 squared is just 11, and that's equal to 1. And that would be the equation of that hyperbola. Okay, so again, different steps here. You have to find the center, find A, find C, find B, and then write the equation. Okay, those are your steps. Questions? Anybody need more time to write this out? Hopefully you wrote out all of those steps so you can follow them. All right, second example here is a little bit different. So if you look at the graph right away, you can see that I have these asymptotes drawn in here. So we're going to have to use those asymptotes to either find A or B. So first thing I want to do is locate my transverse axis to see if this is a vertical or horizontal hyperbola. Okay, so my vertices are these points right here. Okay, I have -4, -1, and -4, -9. So between those 2 points is your transverse axis. So since that transverse axis is vertical, that means this is a vertical hyperbola. So the equation from the front then would be y minus k squared over a squared minus x minus h squared over b squared is equal to 1. Okay, so that's the equation I need to plug my values into. So I need h, k, a, and b. So first thing I always try and find is that center point, which is at HK. So that is, again, step 1. Okay, we'll find that center. So using our vertices of -4, -1, and -4, -9, okay, we can use the midpoint. So average our x's. -4 plus -4 over 2. Average our y's, -1 plus -9 over 2. Okay, so -4 plus -4 is -8. -8 divided by 2 is -4. -1 plus -9 is -10. Divided by 2 is -5. And that was this point. That was already right here anyways. Okay, your asymptotes do meet at that center point as well. Okay, your asymptotes have to go through that center point. So they meet right there. So that is your h and k value. Next, I want to solve for a. Okay, since I have the transverse axis, I can find a. Okay, so our transverse axis we'll have to count here. Again, these go up by 2s. So this is 2, 4, 6, 7, 8. Okay, so our transverse axis is 8 units. And that transverse axis is equal to 2a. So divide by 2 to get a is equal to 4. Okay, next I want to find b. Okay, I'm not going to find c because I'm not given my focus points this time. Okay, however, I am given the equations of the asymptotes here. So remember on the front when I said you'll have to look at the slope of your asymptotes to find A or B. So next we're going to find B. Okay, and we're going to use these asymptote slopes. Now, since this is a vertical hyperbola, okay, the equation for your asymptote is y minus k is equal to plus or minus a over b times x minus h. Okay, so the slope of this asymptote is a over b. So I need to look at the slopes of those asymptotes here. Okay, so I have a 2/3 and a negative 2/3. That's where that plus and minus comes from. So using a over b from that slope, I'm going to set that equal to 2 over 3 because that's the slope from our line. Now I know what a is, right? A is 4. So I'm going to replace a with 4. Okay, then from here you just have to cross multiply to find what b is. Okay, so if I cross multiply here, I have 2 times b. Cross multiply here, I have 4 times 3. It's 12. Divide by 2. To get b is 6. Okay, so unlike ellipses, your a value is not always your greatest value. Okay, b can be greater than a. Okay, so now that I have h, k, a, and b, that's all I need to plug into my equation. So step 4 is to write your equation. Okay, using the form I wrote at the top, we would have y minus our k value, so that's minus and negative, so plus 5, that quantity squared, over our a value squared is 16, minus x minus our h value, so that'll end up being plus 4 squared, over our b value squared is 36, and that'll be equal to 1. Okay, questions on the second example. Okay, so it does depend what you're given. So in the first one, you were given your focus points, so you had to find C in order to find B. In the second one, you were given the equations of the asymptotes, so it's easier to find B in that case. Okay, and I'm just going to highlight my steps like I did before. So 1, find center. 2, find A. 3, find B. 4, write your equation.